In the next chapter, I would like to talk about incremental mode and absolute mode. Most controllers support that through G90 and G91. First of all, I will just program or create an example program to be able to test that and then implement that. So after I will do that in rapid mode so that it's faster. So in G0, after X0, I will move to X100. Let's move, 100. Then again to X100. Then I will make a switch to incremental mode with G91, and then program again X100 and another one X100, and then switch to absolute mode and again X100, and then just see what happens. So the default in CSE is absolute mode, so that's if you do not specify anything, the first movements will be absolute, and after G91 we need to implement the behavior that tells CSE which mode to use, so switch to incremental and implement G91 to switch back to absolute mode. So I will not test it right away, since G91 and G90 of course will produce error messages. So I will just save my program and then create a G90 metacode. I will look up the CSE documentation to find the correct command. That should be set positioning mode. It's also again in the set standard motion section. So set positioning mode has one parameter, and that can be absolute or relative. So let's use that. So G90 is absolute, customize it. Add a child, type a command, another element as a child. What was it? Set positioning mode. Pay attention that you delete the blank if you copy and paste from the documentation, and as a child, absolute. Make sure that you also spelled it correctly. Absolute seems to be correct, and it's a string parameter, so it needs to be in quotes. That's it. I save it. G91 is very similar, so I use the copy capabilities of Machine Configurator and rename to G91 and expand all and replace that with relative. That's it. Yes. Then I can save it, and then let's see if CSE simulates that correctly. Need to make a reset. So first of all, I'm in 0, so the first motion does not do anything. X100 should make a movement. We are in absolute mode, so the next movement should do nothing, since CSE figures out we are already in the position 100. So this means this block does not consume any time and does not produce any motion. Now we switch to incremental mode and move again X100, which is now incremental, so we should get to 200. Another one should bring us to 300. Then we switch back to absolute mode, and then the next X100 should bring us back to the absolute position of 100. So seems like CSE behavior is correct. Now on the Siemens controller, there's a special functionality related to absolute and incremental mode. I will just show you how to program that. You do that in the, so for example, if here, let's just make a G90 to make sure that we are in absolute mode, which is the default, but a good post should output the default values in the beginning. So let's do the same here. So here in these lines we are in absolute mode, but it is possible on the Siemens controller, although we are in G90, it is possible on a specific code to program incremental. So with this syntax, x and then equals IC for incremental and then in round brackets the value, this means that temporarily for this block the x-axis movement will be interpreted as an incremental motion, and really only also for this x address. So if you would have a y100 or 1000, this means the x-axis motion will be incremental and the y-axis motion will be in the mode that is active, in this case absolute. So let's test that how to or see how CSE can handle this, and like I said, that's Siemens specific. Let's look again into our documentation, and where is it? Yeah, here it is, the example. So if you program IC for incremental or AC for absolute, this means that the Siemens parser will produce additional flag that contains this which mode is programmed along with the X or Y and so on. And that contains as a string the this flag. So let's add that to our capabilities in the MCF file. So I need to go to my X address. You see here, by adding the X address, the parser has already created these parameters. So parser for an X will produce the value and a flag. So we need to change our X metacode implementation and now do something with this flag parameter. In this case we need a condition, and depending on the value of the flag we need to behave like this or different. So to do that I'm using to insert an element before, and in this case I use a if command. So also in this XML programming language you can use if conditions. So if command, the child is a condition, and in this case if the flag is nothing, or if flag and 2 equals means that's a comparison. You can find that in the documentation, I assume here in the basic section. Yeah, here you will find the compare operators that you can use, so equal, not equal, smaller than, smaller, equal, and so on. So that's what you can use in the MCF file. So that's a comparison. If it's empty, then we will use this implementation that we had already. So under the if command I need another child, which is a then branch, and now I would like to have this command under the then branch, and for this I can use here the this buttons in XML Notepad to move it under the structure. So this means if this condition is true, then the commands under this then branch will be executed. Now we can make use of these convenient duplicate functions. If you remember, that was Control D. I get the section again, and then we can check when our flag is incremental, then we can behave differently. In this case, if you look at, where was set joint value? Here it is. Set joint value has an optional parameter. If it's omitted, the third parameter, positioning mode, if it's omitted, then the current mode will be used, so G90 or G91. But you also have the capability to specify explicitly in which mode you want to move this joint. So you can specify absolute or relative. And that's what we will use now. So make an additional parameter, add quotes, and copy my relative. So that's the behavior for incremental, and we can just do the same thing for absolute. If I remember correctly, that was AC. Yeah, correct. expand, and then in this case this would be absolute. So that's our handler. So nothing specified, for example just x100, then use the default, the mode that is currently active, and special behavior if IC or AC is specified. So we can save that, save the MCF file. Yeah, I've programmed that already, so we can test it right away by making a reset. So x100 is absolute. Now we should make an incremental movement. See, we are moving to 200. And then again x100 without specifying another G90. CSE remembers that the absolute mode is active, so we're moving back to x100. So that's, and we can do it the same way with AC. You can test it yourself, it should work the same way. So that's a pretty convenient way to handle incremental and absolute modes.